Alright, in this video tutorial, we'll be learning about compensation and subtraction. And once again, we're really connecting to those properties, place value, and inverse relationships. And you'll once again see the power of understanding the quantities that you're working with. So let's define compensation once again. Compensation is a technique we use all the time in math without really thinking about it. It's when we convert a problem to a more manageable one in order to calculate the answer more easily. Alright, so before we move into a few subtraction problems, I want to give you an example of what I do with students in the classroom. This is to get them to understand the constant distance between 2 points on a number line. But what I start doing is I stand over by a circular table, so here I am, and I ask them to count how many steps it takes me to go from the circular table over to the star student area where I have star student posters. So I step and they count 1, 2, 3, 4, 5. And I ask them, how many steps did it take me to go from the circular table over to the star student chart? And they'll say 5. Okay? So then, very dramatically, I say, now, okay, I'm going to start from the star chart, and I'm going to go back over to the table. Count to see how many steps it's going to take. 1, 2, 3, 4, 5. Okay? Not very equal steps there, but just stick with me here. So, either way, how many steps is it? 5. Well, what do you know? It was the same distance. It was a constant distance or difference between the circle table and the star. Okay? So, do some examples like that where students are really having to think about the distance stays the same whether I start here, over at my table, or here. Okay? It's a big understanding for them to recognize, all right? So to compensate means to make a problem easier, okay? So if I take a look and I think about the problem 9 minus 4, okay? I'm good at combinations of 10. So if I were to make this problem easier, I could think of it as 10 minus 4 equals 6. However, because I started with one more than I was supposed to, I actually need to subtract 1 from my answer, okay? Now, another way to look at this would be to think about 9 minus 4 as 10 minus 5, okay? Now, what did I do? I added 1 more to 9, and I also added 1 more to 4. Okay, so what did I actually do? Well, I started with 1 extra, so I had to subtract 1 extra away. So if we were to draw a picture of that, of 9, and I subtracted 4, just draw a line through those, how many do I have left? 5, okay? So what if I thought about this as 10, so I started with 1 more, but then I subtracted 1 more, so 9 minus 5. Do I still get the same answer? I do, okay? Over here I had 9 minus 4, or what if I added 1 more, but then I subtracted that 1 more away? That really is the same as 10 minus 5. Okay, I had a whole group of 10, but I ended up subtracting 5. So it's important that as we have kids think about compensation, you could just tell them, well, if you're going to add 1 more to the subtrahend, and then you have to add 1 to the minuend, for example. Okay? But just telling them to do that without them seeing the quantity representation is not going to be very valuable. Okay? Let's take a look at another one. Alright, so what if we think about 19 minus 14? Okay, I can think about that as 20 minus 15. Okay, Okay, so what did I do? I added 1 to the 19, and then I subtracted 1 more, right? I started with 1 more, and I subtracted 1 more. Is that the same problem? And you could have kids show that problem using manipulatives or drawings. Okay? I often say, if you give me 1 more Skittle, but I eat 1 more, I'm still going to have the same quantity left. So whether I start with 19 and I eat 14 Skittles, or I start with 20 and I eat 15 Skittles, why do I still have 5 left? Well, because we started with 1 more, but we still ate 1 more. So that zeroes one another out, doesn't it? All right, so what if we had 50 minus 28? Okay? So if we look at this compensation on a number line with subtraction, we could think about this as 50. I'm going to think about it as minus 30, but you know what? That would be 20 because that's really easy for me, but then I need to give 2 back because I subtracted 30 instead of just 28. So that would actually equal 22. Okay? So you see how the tool of an open number line can be a helpful visual for us to use. All right, let's try another one. I can think about that as 100 minus 90, I know is 10. But I actually subtracted 4 extras, so I need to think about adding that 4 back in to get 14. Okay, so what did I do here? I actually added 4 here, but then I have to make sure that means I subtracted 4 too many, so I need to give that 4 back. Okay, how would that look on a number line? 100 minus 90. Oops, just kidding, that was too much. I need to actually give 4 back. So 10 plus 4 is 14. Okay, you can even see that my 86 is right here when we think about positive and negative numbers. Okay. So I subtracted 90, but then I added 4 back. So my answer is 14. Compensation becomes really powerful as we think about, have you ever seen students have problems like this? And more often than not, because of they're using that traditional algorithm, it gets to be very messy because they cross out and regroup several times over. So compensation works beautifully so that we don't have to think about regrouping and that type of thing. So I could go ahead and I'm going to go ahead and think about this as minus 1. So I know that's 9,999 minus 7,000. I'm going to subtract 1 from here, 8,401. So now it'll be a lot easier for me to go ahead and do that subtraction. 2,158. Okay, so what did I do here? I started with 1 less, so I took away 1 less. Okay, is it okay to do that? Talk about that, show that. Go back to a simple example of, is 10 minus 9 the same as 9 minus 8? Is the difference the same? Really thinking about the distance or the difference between those two numbers, that constant distance, okay, as we modeled in the example of the circle table and the star. Okay? All right, so here's another great example to help your students understand the difference. So I just give this some dramatic story. I have a student come up to the board and do the recording of the numbers for us, and we have this conversation about why does it always stay the same? What do you notice about the number patterns? So Christy and her sister Jan share the same birthday on December 8th. So Christy, when she was 3 years old, Jan turned 1. Okay? So Christy turned 3 and Jan turned 1. So what was their difference in age? They were different in age by 2 years. Every stinking year, Jan was really hoping she could catch up to her sister. I mean, they shared the same birthday. So every year she was hoping maybe she would catch up. But the next year, Christy turned 4 and Jan turned 2. How much older was Christy than Jan still? 2 years, okay? The next year she thought maybe when I turned 3 and Christy turned 5, their difference in age was still 2. And it continued to happen in this way. Is Jan ever going to catch up to Christy's age? Nope. Tell me what's happening in these number patterns. Now, we don't only want students to look across and see that the difference is 2, or 1 down in the pattern, but what if we look at when Christy was 3 and Christy was 6? What do you notice? What's happening to our numbers? And what you want students to recognize is, and have the conversation of, well, there's a difference of we're adding 3, and then we're adding 3 onto Jan's age. Does the difference still stay the same, and why is that? Now, you can show that on a number line, okay, where the number line you're actually moving the same distance. So on that number line, Christy has moved ahead 3, and Jan has moved ahead 3. So they can see that the distance between 1 and 3 is the same as the distance between 4 and 6. It's a distance of 2. All right? All right, another good visual is you can provide students with yarn or string and a yardstick or a meter stick. And we have a handout on the resources for this strategy that actually is a little worksheet activity students can use to think about compensation. And it kind of looks like this, really. They take a piece of string and they record the starting and ending points. And I kind of talk about it being a road for an ant. So we're talking about the distance of this ant road. And so right now you can see that the ending point of my green string is 3 and it starts at 0. So my road, what is the distance or the difference of my road? We're going to call it 3 units, okay? Now what I could do is, what if I move this string? Okay, now, does the distance of my road change? Have I just adjusted the road? Okay, hypothetically here. So I can look at this, and where does the road end? My ending point is at 4, and my starting point is at 1. So what is the difference or the distance, the constant distance of that road? 3. Okay, so hopefully you kind of get the idea. Now I could even move it ahead right here. Okay, so what if my ending point is 7 and my starting point is 4? What is the difference? Has my difference changed? No. So then you need to talk about the relationship between the sets of numbers. Oh, here we added 4 to both our ending and our starting numbers, or our subtrahend and minuend. What's the relationship you notice here? Okay, so that can be a really helpful way to help kids understand this as well. All right, so let's take a look at a few student examples involving subtraction and compensation. This was a number talk example that was done on chart paper, and the problem was 99 minus 17. So this particular student thought of it as subtracting 9 because that was easy for him. So he took 99 minus 9 to get 90 and then minus 10. Well, he said, you know, I subtracted 19 and I should only subtract 17, so I need to add 2 back to get an answer of 82. Let's take a look at a couple other examples. Here you can see the problem was 600 minus 197. And in this case, 3 was added to both numbers, the subtrahend and the minuend. So in this case, the student thought of it as 603 minus 200, and it was really easy at this point because they're good at subtracting 200 from 603. And here you can see in this example, you know, subtracting across zeros is very difficult. So in this particular case, by subtracting 1, the student really made the problem much easier. So now instead of having 8,000 minus 1,492, we have 7,999 minus 1,491. And then that process of subtracting was much easier. All right, so hopefully you have an idea of some of the ways that kids may represent their method of compensating in subtraction. And I really do hope you noticed that there was very much an understanding of that sense of quantity and how they can be flexible with manipulating those numbers.